was getting a little worried that maybe I had the wrong link. I was here by myself for a little bit.
Greetings, everyone. Despite my best efforts, people seem to have found this meeting. I guess we'll have to keep trying to move it around. No, just kidding. We moved it because somebody had somebody who kind of needs to be here had a persistent conflict for the next few months, and so it was like, okay, last move. So that should be it. Let me post the link in the Discord just in case people didn't follow the thrash. The link there's a document on the web page with the meeting invite links, and those are correct. But let me remind people here. I think Diona, I think you're witnessing the Linux kernel phenomenon of, oh, we're about to do a presentation or a call or a conference. Let's send the patches out beforehand, and so that usually tends to lead to late nights. But don't expect that from me normal times. I was on a roll, and I'm like, either I go to sleep or I can just kick this out tonight and then go to bed. Let me share some slides here. But the slides are brief because I think I want to spend most of the time on the next steps on the PCI stuff. But let's get this going first. I think last time we had trouble with that looks better. Okay. Let me know if that looks okay to folks, if they can see the whole slide.
It looks okay.
It looks okay. Okay.
just okay.
It's okay. With my very flashy template of nothing. Okay, yeah, so go over the ground rules again. This is an open source call. It's being recorded. Don't say anything here that you wouldn't say on the mailing list. This is meant to be a supplement for mailing list discussions. Uh, um, uh, any kind of decisions, technical decisions we're going to make, they're going to be made on the list. So this call is just a supplement for those discussions. And with that intro, a quick reminder about why we're here. This is the Computational Computing Consortium Kernel SIG that Dan Middleton and I started up, mainly with the observation that it helps to get on a call sometimes with folks and talk about technical issues, but also because the assigning devices to talk to private memory has quite a bit more common infrastructure intercepts with Linux, like in the PCI core and in common areas than some other places. And so this topic especially needs vendor agreement or vendor collaboration. And so the agenda for this call is still going to be dominated for the next several months on this topic. Not to say that we can't bring other topics here, but that's the primary. Although today we are going to have a brief update about RTMR, as that's also a multi-vendor standard or multi-vendor concept. Before we start rolling into some of that, I'd like to give a chance for people that have not attended before to just come off mute and introduce themselves and talk about their interest in being here and their interest in following what the community is doing and their thoughts on collaboration in this space. So we do have in the reactions button, you can do raise hand. That's usually the easiest way to get a queue of people going. So go ahead and raise hands, and I'll call people if you want to do an introduction. Okay, go ahead, Sal.
All right. Hello, everyone. Sal. I am the Community Technical Architect for the CCC. Very glad to be here. It's my first time attending because this meeting is usually at 1 a.m. UK time, but I'm on PST. It's 9 a.m. Glad to be here.
Okay.
So you're with the Linux Foundation?
I am. So I'm with the Confidential Computing Consortium, and I am here to support any technical collaboration. So today I'm here to learn and absorb live for a change. So
welcome. Anyone else? Most of the names look familiar, but you don't have to come off mute. Okay.
I guess I'm new to this meeting. I'm
Yeah.
Diana. I work at Google, primarily SubSMP and transparency for the trusted computing race.
Okay, yeah. Well, welcome, Diana, and thanks for all the collaboration we've had so far. Glad you're here to listen to this as well live. Okay. With that, let's go ahead and switch back to the slides here. So, any opens topics? So we're basically going to go through RTMR update. We're going to go through that patch that was sent out at an unreasonable hour my time last night. But any other opens that people want to raise that we to talk about while we're here? And if not, wanted to invite Dan. So you said you wanted to talk about RTMR? Give us an update on where things are. Sure.
Yeah. So one of the reasons that we wanted to put this meeting together was to bring together people who are making use of and developing upon the confidential computing technologies and the people who are getting them implemented within the kernel, because sometimes we don't really get places to talk. One of these areas is for RTMRs. So many of the confidential computing architectures provide a runtime measurement register, or something that's kind of like a TPM PCR, if you're familiar with those. But it's a place to extend measurements, usually of events, but not always of events, into a protected place so that you can later play back those events or whatever it is you're trying to record and see if you arrive at the same hash value as what's been retained in the register. There is a patch series that is now in V2 on LKML. Oops, let me put that into the Zoom chat here. And the really short synopsis of that is, all right, this looks like a good idea, but because often what you want to do is record an event, that API should be oriented towards the event string so that you can atomically both write to a log file and to the register at the same time and avoid there being a synchronization problem. And I think there seems to be general agreement to that on the thread, but then there's kind of the open question of, well, if you're going to write a string, well, maybe that string should have some sort of prescribed format, so it's not just willy-nilly anything. There's a lot of possible formats out there. Some of them that might naturally be picked from, since there's TPM-like usages here, seem like candidates, but there's two factors. One is that we can do things that you wouldn't necessarily do with a TPM using confidential computing. And then second, a lot of those formats are designed for like boot style events. So long story short with that is that the current proposal on the list is a format called NELR. And the way that we wanted to validate that was to take it to the CNCF COCO community. So that's the open source project working on protecting containers, and see if that worked for them. I think we're close to being able to come back to the Linux COCO list with a note saying that that community is in agreement as sort of like a first customer of this AVI, that NELR will work for them. Diona?
Sorry, we don't have a whole lot of people doing this, so I just have to make sure. Did someone from Google's confidential space get to be part of that discussion? Because they do stuff with containers, but it's not the confidential container project.
Right. Yeah, I don't think we have a lot of Google interaction in CNCF COCO right now, but here is the link to the issue, which it painted as a picture instead of a link. I don't know why it does that. Let me fix that. So there's a link to the issue in the Zoom chat, and I'll drop these links into the Discord later. But I think we've, through the CCC, also separately communicated this to other people who are not part of the COCO project. Good question, especially since we want to make sure we got people connected here. So anyway, I think next steps are to kind of communicate that intent and then try to get the patch series evolved from there.
So what you're displaying right now, this event log format, is this for measurements only, or does this also encompass SPDM authentication?
It's for events. So this is the string that you would write to say, I have launched a container, or I'm launching a container with a specific measurement. So like the measurement of the item of interest or the event is something that you would stick in that string. I don't know if SPDM, I'm not sure what an SPDM use case would be here, but I'm open to learn what that would be.
I mean, this is like once we go through SPDM and get the measurements along with the launch attestation, like all of these things are going to be put into a document that we're going to put into this. Eventually going to feed into an event in this record, right? That like this is how we're going. This is one way to validate the provenance of the device with a verifier.
So the reason I brought this up is for my native CMA patches, we had a discussion at Plumbers, and several folks, including James Bottomley, Jérôme Glies, and Jason Gunthorpe, they complained, okay, if the kernel does the authentication and doesn't expose proof of that authentication to a user space, it's useless. So they want the kernel to expose information that lets user space verify that the kernel did everything correctly. And that includes that the entire SPDM transcript is made available to user space. I've just pasted a link in the chat to a commit which I'm working on right now and which I'm adding to version 2 of my CMA patch series. And that exposes the transcript and various ancillary data like the signature and all that, non-sys and in sysfs. Right, thanks. So it's basically a custom log format, and I'm sure everyone detests that I'm inventing a new format. But honestly, I don't know. There doesn't seem to be a better alternative, and that's the reason for my question. If you have if you're standardizing a new format that would potentially could be used for this case, then I'm all ears. But it didn't sound like that's the case.
So,
Gopi? Okay, well, go ahead, Dan, and then we'll go to Gopi.
yeah, I was just going to suggest Bin Xing goes by Cedric. He's also on it. He did the analysis to come up with the NELR recommendation, and I think it's flexible enough that it would accommodate what you're doing. But that's all I wanted to throw in there. Gopi?
Sure. Lucas, you talked about transcript for SPDM measurements, right? I think that's the only way you can verify the output of get measurements call, right? Is the whole signature, yeah, it encompasses the transcript, so there's no other way getting around it. So this particular the IMA event logging is trying to solve a slightly different problem. We face this problem in our devices as well, where if you have say like multiple different software modules that you're loading out of order, right, and capturing all the measurements into a single slot, how does verifier know which order to verify all the modules? And the event log helps out there. We are trying to address that problem different ways here. For example, if you are able to dedicate one slot per software module, then this event log do not make much sense. But where the PCI slots are in limited number, the event log comes in very handy.
Yeah.
So
go ahead.
No, go ahead, please.
Yeah. So it sounds like you're solving a different problem. Did I get that correctly?
Correct. Yes. Yes. And with transcript, I mean SPDM transcript, it's trying to address all the SPDM events. We can try to reuse the format from I'm not sure if it's cell or cryptoagile log, or is a null format? Dan, I forgot the name.
Yeah, that's this TCG PFP specification, and I explained that in the commit message that was just shown. Okay. And they have a way to store certain SPDM information in the log, but they don't store the entire transcript. Yeah, that's called device security event data. That's in the TCG PFP specification. It's useless for my case, but because it doesn't store the entire transcript. And I need to expose the entire transcript to user space. Otherwise, user space can't verify the signature.
Yeah, exactly. right? But yeah, this is going to be very helpful for us, coming up with a standardized log for standards found for the event logs.
It might help you, Lucas, that the same person who asked you to export the transcript is the same person that asked us to think about creating a common event log for this. So you should rope in James on the list on that question, because he's involved. He kind of initiated both of those conversations.
Okay.
Okay, Dan, back to you. Was anything else to share? Just so basically, just so watch this space, and do you want comments here on the issue, or on the list, or where can people get in?
Either way, I think we're the the Cocoa issue on GitHub. I think that's sort of wound down. People are still welcome to comment on there, but I think the intent was to say, all right, here's a first adopter perspective that covers a whole bunch of companies with some wide interests with a container-oriented use case. And so we want to kind of distill that and bring that back to LKML and say, here's the conclusion from one community. So if you've got a use case that's not really reflected by that and you want to bring that feedback, it's probably best to do that on LKML. Yeah, but Cedric is here and he might have some other thoughts.
Yeah, so I just want to leave a comment regarding the SPDM. First of all, I don't know much about that, but it sounds like it's also regarding the transcripts. It sounds like there was something happening, like the kernel need to extract data or verify data, and then it records the result or something to some measurement register using a extend semantics. So if that's roughly what SPDM is, then probably this event log format will work over there as well, but I'm just not certain. So I just want to add some high level design goals for this format. I guess most of the attendees in this meeting may not have a chance to look at what exactly the format is, but the one design goal of the format is to accommodate multiple applications and allow each application to define its own event types. So for example, well, the format is really, so then if you could scroll up the screen a little bit, I just want to show yeah, the example text file. Yeah, yes, exactly. Yeah, here, right. Thank you. So the overall idea is that each line records one event, and then the actual event format will be determined by the first column. So in this example, because this issue was written for the Cocoa project, so we use the Cocoa URL as the project identifier, so that people understand that the rest of the line will be according to the definition by this project. And so if there are other usages, SPDM may be one, and there are other usable applications like a systemd, for example, right? I'm not saying systemd should adopt this format as well, but I'm just saying it's possible that any application, if they want to have their own event types and want to supply additional data to a particular event, they could simply define the event type and parameter and just prefix the whole thing with the URL of their project as a domain separator, so that all applications will not collide with each other. And another comment I have over this format is that it is designed to be per measurement register. So what I'm trying to say is that if there are multiple different measurement registers, maybe from different system components, they do not have to adopt the same format. So basically what I'm trying to say is that if this does not fit the use case of SPDM, it will not become a roadblock either, because nothing prevents this event log format to coexist with anything else. Yeah. that's all. Thank you.
So just one thing to keep in mind, the SPDM transcript can be as small as several kbytes, but it can also be as large as several megabytes. Does your log format accommodate large data blobs like that?
Yeah, so I think it's just a text file. You can keep appending to it, so it really does not have a size limit. Well, I guess if the kernel maintaining this log, then it would only be limited by the available of memory, right? So yeah, and then the other thing, keep in mind that this the idea here that this one line, so each record is one line. So if you need to store a lot of data in single one line, it basically damages its readability from human being perspective. Otherwise, I don't think there are other limitations.
So another thing that's worth mentioning is that every time a measurement is retrieved from the device, or a device is authenticated or re-authenticated, a new transcript is generated. And if we store all of that data in memory, it will continue eating up memory like crazy over time. So there needs to be some way to expire older entries in the log. Has that been considered here?
Well, so for this issue, we only talk about the event log formats, but did not mention the actual implementation. And also this issue is on Coco. So the context is about implementing it in the attestation agent, which is a user mode application. So probably the memory limitation, well, because user mode application, right? They can store things in the on disk or swap out memory pages by the kernel. So those are okay. But if implementing everything in the kernel, I assume the kernel has to accommodate the case of just keeping everything in memory. Then if that's the case, then it might be a problem. I'm not saying that cannot be solved. I'm just not sure. So from Linux kernel perspective, right, it may not be booted with any block devices at all, right? That would be the extreme case. So we have to also assume the pages are non-pageable. So it really depends on your usage. And also the runtime environment. So if we're talking about the kernel has only 128 meg of memory, right? And it's running in a VM booting off initial RAM disk without any external block devices, then of course that's a problem. But if we're talking about putting a machine with maybe 8 gig, 16 gig of memory and like 1 terabyte of disk, right? Then the kernel could definitely, well, at least swap out, even if logically it keeps everything in memory, but technically it could be swapped out to disk, right? So then that will not be a problem. And it also depends on the real size of the SPDM transcripts that you're talking about. You just mentioned megs, but not gigs. Is that right?
Yeah.
Mm-hmm.
Cedric's basically saying it's your problem, Lucas.
Okay, great.
But maybe that does reflect there might be one other open here, which is where that log file actually lives. And I don't know if we've got discussion of that on the thread yet.
Right. Yeah, on this Coco issue, it assumes user mode, so it does not talk about, what if you run out of memory, right? Usually people don't think about things that way when doing user mode stuff. But if in kernel mode, what I can think of is you put this on the temp FS, right? That would get swapped out to the disk if you have a swap device. So in that case, really depends on how much disk space you have, because once you write a log, usually you don't need to read it back until the user will request for an attestation, right? And even if it requests for an attestation, it's still not the time when the log is read, because it just generates, say in the TDX case, it generates only TDX quotes. It's still up to the user on when to read this log. But the one thing for sure is the log is not read often. So it is safe to be put on disk. So it really come back to the problem of what's the configuration of your VM, right?
Okay.
We are about 30 minutes in now, so
Yeah. So
yeah,
so
quick more.
we can switch over. But the reason I was okay spending a bit more time here was part of what's in this new proposal. But thank you, Cedric, for the walkthrough. Yeah, and we will continue that discussion. But the reason what Luca is working on is important is because we want the Common Core kind of authentication ABI that would happen with native CMA to be the exact same ABI we would use for some of the TSM cases. So and again, I'm calling this the TSM layer because TDIS is actually a protocol that's behind the TSM. The Linux host site only talks to this security manager, and TDIS is kind of implementation detail behind that. But if I quickly swap back to Lucas's ABI proposal, the idea would be that whether your device was authenticated via the kernel, native CMA, or whether it was authenticated via the platform TSM, that the ABI for getting the transcript and supplying a nonce and all these details, that it would be the exact same ABI. It just the provider would switch in the background. So that's why I think the CMA concerns are also the TSM concerns. So that we're not having to reinvent new ABIs just because your authentication moved to a different agent. But so I'll continue to let native CMA drive that conversation for now. On the TSM side, the only let me see if I can find the patch. The only ABI we have currently that we share is this authenticated attribute, which just reflects whether the device has gone through authentication and whether you can retrieve measurements at that point. And the idea of this implementation is so the major change from last time, this patch that went out, was that I don't actually directly depend on Lucas's series. In the last series, we had a policy of you can't do TSM authentication until you've completed CMA, but that's actually a policy decision, and user space can enforce that policy if it wants to. If user space cares about the kernel using its own certificate change to authenticate, it can enforce that. If it wants to bypass that and just go direct to TSM authentication, user space can do that too. But in terms of querying and enumerating, has this device gone through authentication of any form? This attribute will reflect that, and behind the scenes we'll be switching providers, but the user space won't notice that. The user space can just assume that this is the place you go to check to see if a device is authenticated. In the CMA case, I guess one difference is in the CMA case you can write to this file to trigger reauthentication. In the TSM case, this becomes read-only, and you need to go through this other ABI to connect or disconnect, because in the TSM case, CMA is subsumed. Like it's not a discrete thing you can see from the TSM. All the TSM implementation might convey to you is a connect verb to connect a device, and that could include CMA and IDE and establishment and And so so that discrete step of like, oh, I only want to do authentication and I only want to do IDE. That's we don't let it get that granular. It's just one kind of coarse grained connect verb. I'm also when looking at this tab, I can't see raised hands. So if people can maybe if Dan, can I appoint you as calling out people raise hands person?
Yes, in fact, Gobi's hand is up.
Okay.
Yeah,
Then
I just
go
have
ahead, Gopi.
one question, Dan. So, in the case of CMA, what does authenticated flag entails? Does it mean that entity has verified the full church sign?
It means that the and maybe Lucas can certainly jump in if I get this wrong,
Yeah.
but it's basically just mutual certificate authentication.
So yeah, so in the native CMA case, the kernel verifies that each certificate in the chain is signed by the preceding certificate in the chain, and the first certificate in the chain, so the root certificate, is signed by a key on the CMA keyring. So the kernel has a CMA keyring, and you can add keys to that keyring. And if you plug in a device and the root certificate presented by the device signed by a key on that keyring, and the chain is intact, and the leaf certificate contains the subject alternative name information required by PCIe R6.1, then the authenticated bit will be set to 1.
After challenge auth. So you have to go through the whole exchange to prove that the thing actually did have the certificate and didn't just provide you with a copy.
Right.
Sure, and the root could also be self-signed, right? It doesn't need to be always signed by a key. In the keyring.
Exactly. Yeah, you could add just that self-signed certificate to the keyring. That would be fine.
Yep.
Okay, but it does not go through revocation check, right? You don't get access to the CRLs or OCSP here.
Sorry, I didn't get that.
You don't go through this authenticated does not imply that the search chain went through the revocation check.
The kernel does maintain revocation chain lists, but it would be policy to inject anything into it. And at the moment, I think not, unless you added that, Lucas.
Yeah, so indeed, so so there is a keyring, and you can add keys to which is I think called blacklist. I think it's called blacklist, and you can add keys to the blacklist, and in that case, they are considered revoked, and those keys will indeed so authentication will fail if a certificate in the chain is blacklisted, or if what the key in the CMA trusted keyring is blacklisted. So in that case, indeed, authentication will also fail. So we do honor revocation of certificates.
Sure, but that's not going to be an up-to-date information, right? So the consumer of this particular flag cannot make an assumption about whether all the certificate in the chain has been fully checked against revocation, the latest revocation list.
Well, it can if it triggers a new authentication, because as Dan mentioned, this is writable, so you can just go do it again. I've updated the certs.
Yeah. You own the search chain in the kernel. So if you put in a cert that's been revoked, then that you get to keep the pieces.
It would be possible to automatically trigger re-authentication of affected devices when something is changed in the keyring. That would be possible. I haven't implemented it so far.
Okay, so if there's a new blacklist available, I can update it and go re-trigger the authentication. At which point can I pick up?
Yeah.
Is there any point in doing that in kernel? I'd just push that to be user space. I mean, the
That's what-
keyring got updated by someone.
Okay,
So-
that's what I'm trying to figure out. I mean, can this be done at the user mode?
I think so.
Okay.
Yeah. The kernel keyring is can be manipulated by user space.
Yeah, there's the key CTL utility. So you just add keys to the keyring or delete keys in the keyring with the key CTL utility, and then you echo one or some other string to this authenticated attribute in SysFS and trigger re-authentication, and that's all.
Okay. And is this blacklist just CRL or is it in a different format?
I don't know. So there is a possibility the kernel supports placing a CRL in the init.rd, I believe. So it will read that CRL when the kernel boots. And I think it's possible to add more revoked certificates at runtime.
Yeah, I mean,
Sure.
that raises a related question, which is at the moment, I think we still only have to manually add certificates. So we haven't done, for IMA and things, there's a bunch of ways you can get them from firmware and things like that. At the moment, this just sticks to new keyring, you poke certificates into it. Now, I mean, we could look at other flows if they make sense for people.
Okay.
Yeah, it would be possible to link the system keyring into the CMA keyring, and then because the system keyring can be amended with keys from EFI and stuff like that, and in that case, those keys would be used for CMA as well. So that there are various possibilities, and we don't know what users will eventually do with it.
The other concern I have, bringing this back to the TSM conversation, is also what I don't know what interfaces vendors provide for managing the TSM the TSM's keyring. So, but I'm taking a note that like if there's this much interest in managing the kernel's native certificate chain, what does that imply for TSM certificate chains and that flow?
In at least some models, the TSM doesn't have a certificate chain. The host makes a decision and then the verification is done by the guest when it comes up. So the confidential container, the VM ends up doing the actual check, and it's the only one that has a cert chain.
But we still need to. I guess we're saying like we do establish ID establishment, secure session establishment, and then we get all the way to the VM, and the VM says, "Oh, by the way, that cert chain that you used was not the one I wanted you to use."
Yes, which is because of the other use of where your normal machine's obviously using IDE as well, and it wants to know that at least the IDE is good. You do need to make sure via this sort of interface that Lucas is defining that the normal host can see what was used to authenticate, even if the TSM did it, and can do its own checks and say, actually, no, I don't like that. Don't use the device for normal use cases.
Oh, that's true. Like, yeah, like we should be exporting this like in the same kind of ABI that Lucas is exporting the certificates that the device sent. We should probably maybe this means that the TSM driver needs to grow a way to export that information via a kernel keyring.
Probably not necessarily the keyring. I mean, the logs that Lucas is talking about will have all the information.
Okay, we get it from the log. Okay.
But there's one sticky one in the definition you've got here is we do need a way to poke in the slot so that you can tell the TSM which device cert slot to use, because if the TSM doesn't have a cert chain, or list of certs, it has no idea at that point which one is valid.
Is that an ABI you're going to add, Lucas, for CMA as a slot selector?
No. So
Okay.
what I'm going to add is exposure of the 8 slots. There's going to be a certificate subdirectory below each CMA capable device, and then you got files slot 0 to slot 7 in there, and those would contain the certificate chains. And basically what I'm going to do is I will fetch the cert chains from all 8 slots if they are populated, and cache them and make them available in SysFS. And I will also add a link from the signatures directory to the slot. So each time a log entry is added to the signatures directory, you get a symlink and you know which slot was used to create that particular signature in the log. Yeah, and otherwise, no. So far, I'm not planning on letting user space select a particular slot. I will just go through all available. So currently, I'm going through all available slots and try to verify if the search chain is okay in one of them. And as soon as I discover a slot which has a valid search chain, I will perform challenge response authentication using that search chain.
Okay, so maybe we can cross that bridge when we get to it in terms of
Right.
when, like, if somebody's like, if two of them are there and you wanted to get the second one, not the first one, then maybe we need a selector.
Well, the selector for the kernel is that it only would have the certificate of the one you wanted to use.
Okay.
Now, I mean, whether you might potentially want to use certificate A for device B and certificate C for device D, despite the fact that they both have the roots for each, yeah, maybe. But you'd hope if you trust a cert, you trust a cert.
Yeah.
Correct.
And you don't get into a mess. And in that case, all you'd want is a read-only API that said, well, the link you've got may work for this, Lucas, but just says 3. But on the TSM version, you'd want to be able to write that in some fashion to say use 3.
Okay. So that was but that's our plan to integrate with CMA in the sense that, like, there will be a CMA API, and if your application knows how to use that, it will also know how to use the TSM thing, and vice versa. Modulo these extra this TSM subdirectory, which has ways to invoke the TSM verbs like connect and disconnect. So as for RFC, yeah, those are the only verbs that we're defining right now. Just connect and disconnect. The other kind of subtle change was.
Hey,
Well,
Dan, sorry.
oh, sure.
I have
Go
one
ahead.
question before you go forward. So this authenticated flag is a property of a physical function, right?
It's a property of physical function, correct? Yeah.
What happens for the virtual functions?
That was going to be the next phase of this, was to figure out do we just reuse the same host side API? Like, so maybe with the idea being that on the physical function side and the host side, connect is for reflecting SPDM and ID establishment, and maybe on the guest side, connect can also be there, and it reflects whether the device is bound or not, bound and accepted, or these kind of flows. But I haven't gotten that far. But I'm waffling on whether that we should try to duplicate the host API or really make it look like this. The guest side is different because it's doing acceptance of MIO and DMA, and it's a different flow than the host connect side. So
Right. It can also do his own authentication of all the search chains, right? It could have his own different keyring, blacklist, for example.
in the
So,
VM, yeah. Well, I mean the deny list on the host side would be different than the one on the guest because it's a different process.
But the IDE setup has already occurred, so it has to trust the IDE, the physical function, whatever.
Yeah,
it could look at the log of what was in use and go, no, don't trust that. Or it could, yeah. I mean, you have got a question of you can't re-authenticate because you'd tear. I think if I get this right, you'd tear down IDE if you did. If you wanted to use a different search chain, unless you had one of those potential VFs that actually has its own instance of CMA and it has its own DOE mailbox on the VF. No idea if anyone's building that, but the spec does allow it for the purposes of authentication.
But your IDE would still be.
Yes, the IDE is always in the physical.
Still physical, correct. Okay.
But given the number of parties on the VM side that want to look at all of this, I feel like on the guest side, it's going to be different, where it's going to be like we're going to have this this TSM state of the PCI device object, and in the guess that'll be either a virtual function or a physical function kind of object, and it should be the case that user space, drivers, everybody can find some way to get back to this material and verify. Yeah, user space says it's okay, driver says it's okay, and get that going that way. But first, yeah, but first step is really to get like the main goal here is describe this in a way that Bjorn's like Bjorn can say, yeah, this is the way I want this stuff to integrate into the PCI core, and this is the way vendors like get this kind of blessed as the way vendors get their TSM concepts enabled. I do notice that we are the only host vendor on the call, which is kind of whatever. It is what it is. But like this is no secret. I work for Intel. This is Intel is going to adopt this. I'd like at least one other vendor to say, yep, that we're going this way. Nobody has come out and said they hate this and they don't want to go this way, but like until somebody shows me that they did the work to integrate this and prove it out and send bug fixes and that kind of thing, I think it's still in the RFC phase. So
isn't Huawei a vendor?
Yeah, I was going to say technically a host vendor, but not a controller of this sort of level of specification. But we'll poke the relevant people, you know.
Yeah,
we are a host vendor.
That's true. That's true. I guess I was considering like the folks working on like the ARM CCA stuff. They're not here.
No, I'll kick them again.
Yeah, if you can.
It's been a whole week since I last pointed out they should be here.
Yeah. So, but I have pretty good confidence that'll happen. But as of today, still RFC. Anything else I wanted to point out here? This was more your feedback, Jonathan, and it's really more relevant for TDX. But like maybe this is relevant for Revos and maybe ARM too, since their TSM is also not really a device kind of firmware thing. It's actually like a platform module execution mode. What we did for TDX was create there's something called subsys virtual register in the kernel, and it's basically saying like this is the catch-all. This is a place where you create SysFS ABIs for things that don't have devices, and so we use that. The WorkQ subsystem uses it to create WorkQ devices. We're using that here to create a TDX bus and a TDX TSM device, and so that kind of answers also Alexi's concerns. Alexi from AMD was saying like, I want this to be modular, and so this TSM layer part is modular. The core integration is built in, just like CMA is built in, but the actual low-level driver from the TSM provider can provide, that can be a module that can load late and that can have its own policy around it. So it kind of it splits the difference. You can't replace the entire TSM enabling, but like the bulk of the thing that's going to need the most updates and something that you might want to replace at runtime, that thing will be in a module and we'll have a driver for it. So the way this works for TDX is this TDX TSM device pops up at some point that loads its driver, and that driver registers with the PCI core saying, hey PCI core, there's a TSM now. So if any of your devices supported IDE or TEE, send them my way and let me evaluate them and let me turn on this SysFS ABI now that I'm here. That dynamic ability to like make a group of SysFS files pop up is new in 6.9, so that's this SysFS group visible thing. And that's pretty useful because now we can statically define the ABI keep it hidden until it's actually required. And we're going to use this visibility also to switch between CMA and TSM ABI. So as on the kernel side, CMA will become invisible and TSM will become visible, but they'll be the same file name, and so you really won't know. Application that doesn't care about the difference won't notice. So we're using those tricks to make things flexible. Anything else I want to say about this? But I did go ahead, and this is a comment from Satya, is split the driver's virt Coco directory into a guest and a host side split, because there just kept being things that we needed to do on the host side that are computational computing related. So we just went ahead and threw everything into a host side directory. But otherwise, all of this common core stuff is happening under drivers virt Coco.
Am I remembering correctly that there was a email saying we hope we don't have to do this split, and that's going to be obvious that the TSM is in the guest?
A email saying don't do the split, or
just hopeful that the split wouldn't have to happen, but things are complicated.
Yeah, I mean, maybe if you point me to that thread, see if I understand the concern, because like the guest side infrastructure that's common are things like attestation reports, like VM launch attestation reports, which makes no sense for the host, and like IDE establishment for physical functions makes no sense for the guest. And at least me as a kernel developer, like I want to know what side of the driver I'm working on. But yeah, if there's an opinion out there about please don't do the split, try to keep it look the same, I want to hear that and respond to it. But yeah, so I mean, so we'll continue pushing this from the Intel side. I think next. So the other kind of observation is that it's kind of difficult to validate these things without hardware. To validate, hey, do I have the right ABI? And you have to stand up this whole deck house of cards to get it working. One of the techniques that I used in CXL and NVDIM subsystems is this idea of mocking sysfs objects. So as far as user space is concerned, it looks like the real thing, but behind the scenes we're actually injecting fake PCI devices, fake everything to and so it's different than QEMU because it cuts a lot of corners, but it lets you develop the kind of tests alongside with the kernel code. So one of the things I'm thinking about is injecting a test PCI host bridge that pretends to say, yes, the devices are here. Yes, they have these capabilities, so that just so all the sysfs ABI lights up without actually having to talk to a device, and hopefully that lets people play with it a bit more. So stay tuned for that. But yeah, my main goal is introduce that this thing is out there. Talk to your talk to your other host vendors and get them to take a look at it. But other than that, our next call will be in 2 weeks. It'll be at the Thursday evening Pacific time to catch Australia and China folks that are interested in this topic.
For those that didn't want to join between midnight and 1 a.m. today.
Right, right. Yeah. These times are quote unquote Europe friendly, China friendly, but they're mostly U.S. Pacific friendly. So sorry about that, but yeah, we do alternate to try to capture both sides of the globe. Surprisingly, there's no good time slot to get U.S., Europe, and China on the same call.
I think that's cool. I think Wenhui, I think you're dialing in from like 1 a.m. now. Maybe a couple other people out there. So that's cool. Not my choice for a Friday night, but I'm impressed with yours.
Okay, well, we reached the top of the hour. Any parting comments? If not, thank you for your attention, and we will see you all next time.
Thank you, Dan.
Yep, have a good evening.
Thank you. Yep.